scanning, it becomes more possible than ever to achieve design certainty. With design certainty, there are new opportunities for saving time and project cost. PMC has been utilizing scanning for 15 years and is well versed in the evolution of the technology, helping clients avoid mistakes and pitfalls made with earlier versions. Traditional methods of field measurement have improved over the years with laser distance measuring devices, but are still fallible due to human error. Getting measurements in heights over 10 feet tall or taking measurements on an uneven floor will result in errors. There are also problems with assessing relationships among elements. Most projects will require multiple trips to the site to recheck measurements or take additional photos. The traditional method of creating a true as-built of existing structures can be time-consuming and expensive. Rarely are accurate plans available, and most often field measurements have to be verified multiple times. Using digital laser scanning, the accurate data is captured one time and can be converted directly into the CAD model. This chart shows the transformative changes in the technology of laser scanning. In the early stages, an average of only 24 scans could be captured in a day. With the advancements of faster and lighter field equipment, the productivity of terrestrial scanning is now an average of 185 black and white scans per day. New software tools, such as Autodesk Recap, have also led to faster processing of the data. This is a typical workflow for terrestrial scanning. There are various options based on specific desired outcomes. Probably the most important step is to create a detailed map of specific locations within a facility to scan. This ensures that the field team will capture the right amount of detail required for the projects. For example, are there drop ceilings? Is there adequate light for a color scan? Or do you need all aspects of the MEP systems? Then the field team will scan, bring scans back to the office to register and process, then hand off to the design team. Today, terrestrial scanning is used in all phases of project development. The advancement in laser scanning equipment and supporting software has made scanning cost-effective in all aspects of an AEC project. While the traditional points of use are still in the schematic and completed project phases, we will be examining its value throughout the design and construction phases. Using specialized equipment, we can scan inaccessible areas such as small tunnels, roofs, and shafts. Higher accuracy equipment can be used for reverse engineering for high-detailed architectural elements. Our first case study focuses on a project we completed on a building that was over 100 years old. There were no existing as-built models available, and field measurements weren't accurate. Errors found during the course of demolition prompted the general contractor, SACSI, to call in PMC. We completed a deviation report of plans versus actual. This is the point cloud data from our exterior scans. It was possible to overlay the scan data directly on the CAD layout to visualize the variances and where corrections needed to be made. This saved countless hours of corrections to be made on the construction site and cost overruns. The color chart gives a graphical display of the dramatic floor level deviation. The red indicates plus 5 inches and the blue indicates minus 5 inches. The original remediation plan was to pour concrete to level the floor, but the 10 inches in variance called for alternative plans. This saved countless of hours of corrections to be made on the construction site and cost overruns. PMC's expertise in architecture allows us to work with the scan data in many formats, giving the optimal views required for a specific project. Architecture is dependent on photos of existing elements, but also requires relationships between elements. Photos can show existing conditions, but cannot determine exact relationships between elements. During the scanning process, the digital scan is taken, and in the same position, an associated photo is taken to provide the ability to compare and contrast. Estimates for the field measurements were supplied by the architect. These were based on similar projects of similar size and condition of existing structure. Another difference that is not in this chart is the amount of delay associated with manual field checking. The total number of days was 18, but the overall time span could have been months, depending on the project location and the amount of travel. This is another case study showing the benefits using laser scanning. This project was a 10-story abandoned building. Scanning was the only way to document accurate exterior dimensions. This is a scan of the elevator shaft. There was no light available. Black and white scanning can be done in total darkness. The structural engineer needed to determine the viability of existing conditions of the shaft. Note the conduits on the side of the shaft. These were not documented in any of the plans, and they were unknown until they were picked up in the point cloud. As the building had been abandoned, the condition of the roof was unknown, and safety precluded manual field measurements. The scanning could be safely done from a lower roof using boom equipment. While there are many advantages to having just an accurate as-built of a facility, let's explore the many more uses for laser scanning in architecture. Architects can quickly create demo plans by drawing directly on top of the point cloud, making accurate demo plans with exact dimensions. This frees up time to move directly into new drawings or models. During schematic design, models for true as-built conditions can be created in far less time than design for manual measurements. To visualize proposed changes, new elements can be added to the model to evaluate multiple scenarios. The mezzanine shown in this model helped visualize the proposed changes and verified spacing. Laser scanning has been used in industrial projects for years. The complexity and density of plants makes it difficult to verify clearances without an accurate as-built model. A mistake of just a few inches will necessitate major rework and field changes. The rapid evolution of laser scanning has reduced the time and cost of producing a point cloud of a facility. PMC can add value to construction reviews by overlaying the model directly on the point cloud, checking accuracy of installations. With the proper planning and scheduling, PMC can accomplish this on the day of the review. Many potential errors aren't readily seen in a 2D perspective. For this project, PMC converted the proposed 2D drawings of a new piping system into 3D and overlaid on the point cloud. This allowed detailed review of plans versus reality, all in a very short turnaround. At another point, the 2D drawing didn't accurately show the height of a fencing, which would have been a very costly field change if the collision had not been detected by the use of laser scanning. Using this method of evaluating the piping route, many small interferences with existing light fixtures were also visible. Scanning can also be used to facilitate the bid process with subcontractors. For remote job sites, the review meeting can be held online, eliminating the need for everyone to travel. Additionally, the data files can be posted for additional reviews. Everyone will be working with the same data, and multiple trips to the job site can be eliminated. The gray orbs indicate the location where the individual scans were taken. By clicking on an orb, the user can operate a virtual tour of the area, including dimensional data. Our experienced team of subject matter experts and technicians can be an asset to your firm by utilizing our partner-based business model. We don't just deliver data, we deliver solutions that meet your specific needs. As a leader and innovator in digital engineering, PMC is constantly evaluating new technologies to bring to our clients. Aerial drone scanning allows us to provide solutions for documenting data that isn't easily captured from the ground. This is the traditional laser scan of the Fisher Building from ground level. As the height of a building increases, the angle of the scan steepens. The line of sight requirement for the scan will eliminate data at the higher floors, such as depth of ledges. Combining the laser scan with the high-resolution drone video will give a full assessment of the exterior conditions. While there are tools available, such as Google Earth, they won't be accurate in a detailed view of a specific structure. This is the resolution from the drone video. The objective of this project was to provide data that a structural engineer could use to pinpoint specific areas that needed to be physically inspected. With the help of PMC, the engineer could greatly reduce the number of physical platform drops that would have been required. Laser scanning is one of the many technology tools that adds value to an AEC project, from 2D to level 400 BIM. With PMC as your technology partner, you can be assured access to the best-of-breed technologies for the AEC sector.